What do you know about roof drains? In this video, we're going to have an up-close look, so stay tuned. Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello, welcome to this video where we are going to have a close look at storm drains, or roof drains as they are often referred to in the plumbing trade. If you're plumbing and spend any time in commercial work, you will very likely be involved with the installation of roof drains. Overall, they're fairly simple, pretty basic to install. But they're also very important as they convey water from the roof to the outside and keep the building dry, of course. Now, these are primarily used for buildings with flat roofs. Anywhere you have a pitched roof, of course, the water is going to flow off the roof, and exterior rain gutters are installed. But in many commercial buildings, they have a large flat roof. And when I say flat roof, I'm saying generally flat. There is a slope to it, there would have to be, and the slope does run to the roof drain locations. But it's generally a flat roof. The structure is strong enough to hold whatever, weight of snow or water is piled up on the roof, and water is brought to these storm drains. Now, you have to understand with any storm drain, there are going to be two identical pipes. One of them we refer to as the primary drain, and the other is the secondary drain or the overflow drain. Now, these roof drains are designed to manage the amount of water that is anticipated in worst case scenario on top of that flat roof. Say we have a 100-year storm and it dumps like crazy. It has to be able to hold that much water. But the secondary drain or overflow roof drain is installed and designed, again, the exact same diameter as the primary drain, but its purpose is to convey the water off of the roof if the primary drain gets plugged up. So this way we have a backup, and that's all that it is for. Now, the primary drain typically runs down and connects to storm drainage outside the building. That may be a pipe that runs underground to some other storm drain system. The secondary drain is required to convey the water to an outside location where it can be observed. Typically, this is a scupper coming out the side of the building. We have an example here of a cow tongue type scupper, a large brass fitting that's just going to dump that water out away from the building. This is so that if, again, the primary gets plugged, the secondary can convey the water out, but you would want to know that's happening. And so, when you see water coming out of there, then, it's time to do some maintenance. Once again, these are the same size, they are run in parallel. They are installed early in the construction of the building. In fact, it's one of the first systems that is put in after the structure. And this is because the roof drains have to have slope. They have to be able to move through that building with slope to convey water out to where it needs to go. So often it goes in before anything else, ductwork or other plumbing, piping systems, electrical systems. Now, they are similar to other drains. We're talking drainage, waste, and vent. In that, we use the same materials. You can use cast iron with no hub, or you can also use PVC or other approved drainage pipe and fittings. And they also run with similar slopes. 1/4 inch per foot is ideal. With larger pipes, you can go 1/8 inch per foot. These slopes are designed to convey that water out through the pipes. So in this way, roof drains or storm drainage are very much like drainage, waste, and vent. However, they are different than drainage, waste, and vent because we can drop the last part, venting. There is no venting required for storm drainage. It's just one big, wide open pipe that opens and conveys that water out of the building. Now, it is okay to branch these drains together. So you may have several sets of roof drains that run together into a larger roof drain, and then that is delivered out to the storm drainage system or the overflow. In those cases, it's very important that you don't cross the primary and secondary drain connections. These are two completely independent systems, and you wouldn't want to have any cross connections as those are installed. Now, Roof drains are very often installed with insulation. The insulation is going to do two things for us. One, it's going to keep it a lot quieter. You can hear water moving through pipes in a ceiling, but the insulation is going to muffle that. The second thing the insulation will do is to keep water from condensing on the outside of the pipes. If you're inside of a heated building and there's any moisture at all in the air or humidity, and you're dealing with water that's coming from the outside, so that rainwater or even melting snow is going to come in and it's going to be very cold. The pipe will be cold. And a cold pipe exposed to humidity or moisture in the air is going to create condensation. The water will collect on that cold pipe and it will start to drip. So the insulation is actually going to protect the inside of the building from condensation and water damage that can happen because of condensation. Let's have a quick look at roof drain assemblies. How does the roof drain actually connect? On top of the roof, you're going to have a bowl. This is the actual roof drain. And on top of that, it's going to have a ring that will adjust the height to which the water can come into the bowl, and also a basket strainer that's going to keep leaves, branches, and other junk that lands on the roof from going down the drain. This is the top side. Now on the underside, these roof drains are going to have a bracket that fasten that roof drain down to the decking or the deck of the roof and are going to create a really tight connection against the roof. After these are installed, the roofers will come in, slope the roof material to the roof drain, and put a membrane or the actual waterproofing roof material on the top of all of that. The membrane actually comes right into the bowl of the roof drain and is glued, sealed, clamped, compressed right to the bowl so that any water coming from the roof goes into the bowl. It doesn't leak out to anywhere else. And that's how we collect the water from the roof and convey it down into the storm drainage system. Roof drains are supported using your typical pipe support means. Very often in commercial settings, we're going to see the use of strut and strut clamps, and there's any variety of ways you can put that together to help hold up the pipe. Riser clamps are going to be helpful to hold those vertical roof drain pipes in place as they pass from one floor to another. And of course, all thread and Clevis hangers are going to be a very common way of hanging all of these roof drains and supporting them properly. They are supported just like any other drainage pipe at the given intervals that code would require. But it's also an important thing to note, when roof drain Clevis hangers are installed, you want to oversize those hangers big enough so that the insulation can be installed in the same hanger without having to redo the hangers after you've hung the pipe. An oversized Clevis hanger can be adjusted down on the all thread, making room for those insulation sleeves. The insulation that is installed in those hangers is a rigid insulation made of calcium. They're calcium blocks that can hold the form but also insulate the pipe. So when creating roof drain Clevis hangers, make sure to leave enough all thread so that those Clevis hangers can be adjusted down as that insulation is added. Hopefully this is a helpful tutorial for you on what roof drains are all about, how they work. This should give you a better understanding for studying roof drains or storm drainage in the international or uniform plumbing codes.